So moving on to the mixed practice, the first problem is alpha decay of TH235. So we want to start by writing out the full nuclide notation for that isotope. So I will start with TH, the chemical symbol, and then I'll put my mass number 235 at the top, and I need to look up the atomic number. So on our periodic table, we can go and find that element TH, and it is in the F block. TH is right here, and it has an atomic number of 90. So that's what goes on the bottom of my nuclide symbol. Now we are having this isotope undergo alpha decay, which means that it's going to emit an alpha particle. And when this happens, an alpha particle is basically the same as a helium nucleus. It contains 2 protons and 2 neutrons, so it has a mass number of 4 and an atomic number of 2. And then we can either write He, which is helium's chemical symbol, or we can just put the alpha symbol next to that. And we just need to figure out what other thing is emitted, what isotope is the other emission of our alpha decay here. To figure this out, we'll just see what numbers we need to add to 2 and 4 to get back to our original value. Or the other way to think about it is 235 minus 4 gives us what number. So we'll start with a mass number. 235 minus 4 gives us 231 as our mass number. But our mass number doesn't tell us what element we have, and so we need to look at the atomic number. 90 minus 2 gives us a new atomic number of 88. So then we will need to go back to our periodic table and look for element 88, which is right here, and Ra right on. So Ra. And so that is the alpha decay of TH235. TH235 decays into an alpha particle and radium. Now we'll move on to beta decay of uranium-235, and we'll start by writing uranium's full symbol. So uranium-235. Then we need to figure out uranium's atomic number. It is, of course, atomic number 92 down here in the F block. And if something is undergoing beta decay, that means it is emitting a beta particle, which is the same as an electron. So an electron has almost no mass, negligible mass, and then a -1 charge. And we can either put the beta symbol or can put the electron symbol. And then we just need to figure out what else is being emitted. So when something undergoes beta decay, when this happens, that means that one of our neutrons is becoming a proton by emitting a beta particle. And so it does not change our mass number, because if we have a neutron becoming a proton, those both have the same mass, but it does change our atomic number, because we have an additional proton. So we can figure this out by saying, okay, what plus -1 will give us 92? And of course the answer to that is 93. So 93 plus -1 gives us 92. And then what plus 0 gives us 235? Well, we still have that mass of 235. So now we just need to figure out the element that has atomic number 93, and that is neptunium, which is right here on the periodic table. Oh, not there. In P, right here, 93. And there is the beta decay of uranium-235. Last but not least, on this page, we are doing La-131 emitting an alpha particle. So we'll start with our isotope. La-141 is that mass number. So now we just need to figure out the atomic number of La. We'll look at our periodic table. La, lanthanum, is right here on the periodic table and has atomic number 57. So we'll fill that into our isotope notation. And then it is emitting an alpha particle, so that means that it is a product. So when it emits an alpha particle, alpha is 4, 2, and this time I'll put He. We just need to figure out what the other thing that is emitted with that alpha particle. And to do that, we'll make our numbers add back up to our original isotope. So 57 minus 2 will give us our new atomic number, and that's 55. And then 141 minus 4 gives us our new mass number, which is 137. So let's figure out what element number 55 is. We need to match that atomic number to an actual element. So looking at our periodic table, element number 55 is cesium, CS. CS. So there is our full decay equation there. Lanthanum 141 emitting an alpha particle and producing cesium 137. Number 4 says a neutron in the nucleus of bromine 80 breaks down and emits an electron, which this is just the process of beta decay being described for us. So a neutron breaking down, emitting an electron, and becoming a proton. So we're just writing the beta decay equation. We'll start by writing bromine 80's full isotope notation. Bromine, that 80 is the mass number, so that goes at the top. And then bromine is atomic number 35. And if you're not sure, it is right here on the periodic table, 35. It's a halogen. And so we're breaking down and emitting an electron. And since it says electron this time, I am going to use the electron symbol and not write the beta symbol there, although they are the same thing, have the same effect. And we just need to know what the other thing that is emitted after we have that beta decay happen. So we know that the mass number stays the same, 0 plus 80 gives us 80. And then the atomic number is increasing by 1. So 36 plus negative 1 gives us 35. So if we look for element number 36, it's right next to bromine. It is krypton, Kr. So there is our decay equation there. Number 5. Ra, radium-230, releases a high-energy photon. Okay, so that high-energy photon, we know that that must be a gamma particle. And a gamma particle is just a lot of energy, but does not have any mass and doesn't have any impact on the atomic number either. So all we're going to do is write our isotope notation for Ra-230. Ra-230, right there. Radium's atomic number is 88, so we'll fill that in. And then we know that there is no effect on the mass or the atomic number, so we can write that same isotope on our product side. And we just need to show that high energy photon, which is our gamma particle. So a 0, 0, and then the gamma symbol. And that is a pretty easy one. You just have to know that high energy photon corresponds to gamma radiation. Last but not least, number 6, the nucleus of PO211, or polonium-211, gives off an alpha particle. Okay, so this is an alpha decay equation, so we'll start with our isotope PO211. 211. Polonium's atomic number can be found on the periodic table. It is 84 right here on the periodic table. Let's see, 84. So we are giving off an alpha particle. So on our product side, one of our products is going to be that alpha particle, 4,2He, and we just need to figure out what the other product is. So we need to figure out what plus 2 will give us 84, and of course that is 82. And then what plus 4 will give us 211, and of course that's 207. And you are always welcome to use a calculator if you need one to get this math. Looking at our periodic table, we just need to find element number 82, which is lead. Pb is lead. So we'll put Pb. And there is our full decay equation.